Okay, let's go ahead and get started. So thank you for joining us this afternoon, evening. Right, we're about to endeavor on some causal inference. How many of you have heard of, and can you hear me okay? Give me a thumbs up. Yeah? All right. How many of you have heard of causal inference? Thank you. And how many of you use it in your workflows today? Not yet, right? We studied it in college or in our grad program, but we haven't used it yet. So I want you to think about right now with me, go on a journey we do our statistics, right? And we're looking for associations between two different variables or a story that the data is going to tell us. We test it with rigor, but we're not testing causal relationships. We're testing, is there an association? Is there a there? Right? But causal inference takes it a step further. It's a little more sophisticated, and we're seeing that regulators today are looking for more than just associative statistics, right? And so today we're going to talk about causal inference, but I want you to think about how many of you have VIA today. All right, we love you. Thank you. We're happy to do more use cases with you. How many of you are looking into investing in VIA? All right, very good. Come to the booth. We're happy to have deeper conversations with you. In VIA, right, in SAS in general, SAS 9, we have our base stat and graph. We might have econometrics packages. These statistics have been ported over from SAS 9 to VIA. And so these are some of the things out of the box that you get in visual statistics, right? And this is kind of the most common package of VIA that we're seeing our customers invest in today for continuity of their business and to further their innovation in the analytics that they get. Including in this visual statistics, right, is some causal analysis. Right, so has anybody ever done causal analysis outside of their grad program? No, all right, awesome. So let's talk about what causal inference is, right? Not, hey, is smoking associated with weight loss? That could be a question, right? But hey, is smoking associated, in what way is smoking associated with weight loss or weight gain, weight in general, right? And so instead of saying yes and no, I reject or accept a null hypothesis, I can actually go a little deeper and say, what is the nature of this relationship? So causality is really when you can test if one particular event or variable directly influences another, and what magnitude and what direction, right? So it's vectors. Do you remember vectors in geometry? Right, it was our favorite class, right? Some people didn't like it. Some people never took it. It's okay, right? But I want to know, how hard am I pushing in what direction, okay? Or am I being pushed, okay? And what kind of direction that is. And so the causal inference then determines if this cause and effect, not just association, right, exists in a population, and it quantifies it. So not only how hard, but like it will cause weight gain by this much on average. Okay? And being able to be that precise allows me to really truly assess, is this really something that I can intervene in, or an expectation of an outcome that I can adjust for or have a conversation with the regulators around. So more and more, the EMA, the PMDA, and the FDA are asking for more and more causal inference and causal analytics. And this is a really great way to use it in SAS. Okay, so who uses causal inference? Well, the EPIs. Hi, I'm an epidemiologist. Sorry, I didn't introduce myself. My name is Shireen, and I here at SAS lead our observational research, our epidemiology and real-world evidence practice. Right, so I get to use VIA and SAS 9 with really smart people that are technical here at SAS, as well as partners who are really innovative and full of really creative ideas, and actually push the limit so that we can actually shepherd our industry into something more innovative and more responsible for our patients, right? But epidemiologists, data scientists, we all do causal inference when asked, right? And public health professionals, social scientists. Why is this actually though important? What can causal inference do? Have you ever heard of a trial emulation or a target trial emulation? This is the analytics behind that allows you to do that with the data that you have that may or may not be a randomized clinical trial. It could be some of your real world data sources like a registry, like your claims data or your national health data, right? And so why do I want to do this? Well, there's one thing. I want to maybe see if there is a causal relationship, not just a correlative one, right? I want to be able to make a stronger claim, right, that this impacts this in this way, in a quantified way, and then actually actionable for policy and regulators, right? And that means like when the FDA says, I need you to prove that you don't cause this, that your product does not cause this negative or this adverse event, and not just, hey, maybe there's a probability, I'm able to actually quantify that relationship if there is a true relationship. So let's talk about what the typical workflow is for causal analysis, right? First, what is the causal question, right? What effect is of interest? Is there a weight gain or weight loss, right? The treatment, the outcome, the population, the timing. Also, what is a data generating process? I need to know how the data was generated, and that's where EPIs really shine, right? Because it will impact the way I'm able to interpret the results, right? Because I'll know limitations, but I'll also know the practice by which it was actually generated. Also, how are these variables related to each other over time? Is there a difference, right? So we actually were able, in this use case in NHANES, using NHANES data, look at the average length of duration of quitting smoking for 10 years. So over 10 years, there's an average weight gain of 3 pounds, right? 3.3 pounds. Right? And then what data and assumptions are needed? Do I have the right data fields? Am I missing something? Is that actually a limitation? What are the likely drivers and the confounders? Is the data structure suitable? We're actually running something for an RWE challenge with Fuse that we're presenting in July. And we're realizing that there are some structured variables there that are not applicable, nor are they lending, they're actually maybe adding more confusion to our DAG, to our directed acyclical graph, right? And then how should that effect be estimated, right? Is it over time? Is it on average? Is it yes, no, right? In what dimension, right? And then what causal method is appropriate? There are a few of them that we actually have out of the box. And then how do we address heterogeneity and hidden bias, right? There's always bias in the data, right? If you're working with some claims, some insurance claims, for example, it could be the working wealthy, right? And in other claims, like if you're using Maccabi or Clalit, I've used that data in the past, it might be too homogeneous on one population. So when I want to take my findings from that particular study and I want to take it to another country, the country might say, no, that's not diverse enough for us, or it's too homogeneous for me, right? And then how do I turn that evidence into action? I'm not just doing this because I want to see that it is actually a gain of an average of 3 pounds. I want to maybe put that patient, I know it's going to take them about 10 years, get them as they're starting to talk about their smoking cessation, maybe I can intervene and say, hey, I'd like to be able to get you on a lifestyle regimen, right, where you're walking regularly, because over 10 years, I want to be able to avoid you actually gaining those 3 pounds, because for every pound that you gain, it might actually have another adverse effect on your metabolic health, okay? And so how can I look at that workflow with SAS? Well, first, I want to be able to, there's a lot of procs out of the box, right? I like that. And these procs out of the box are actually, they are warranted and guaranteed every time you have a deployment, because we warranty and guarantee our math, right? And so you have proc causal discovery, causal graph, proc BART, causal med, causal treat, CA effect, PS match, super learner, deep causal, and deep price. Some of these actually are on SAS9 and VIA, and some of them are only exclusive to VIA because of the compute power that we have access to in the way that we can develop our standards, right, and our procs. And then finally, deep causal and deep price. If I'm looking at this over time, right, first I want to discover and understand what my data looks like and what my options are. Also then, I want to be able to graph using directed acyclical graphs, for example. I want to be able to test the inferences, the estimates, the assumptions, and then finally design and evaluate those interventions, the what if scenarios, because that's what we're doing. How does that work out of the box? Well, you'll see some of these outputs, right, are, can I point here? Yes, I can point here, right? You'll have some of the data. I guess I can't point very well, right? You'll have the data, the DAG, and some of the inferences out here. And then what happens when I hit a threshold, right? This what if scenario. What if I do this? How will that affect what I have? Finally, if I want to go into a little deeper, right? This causal discovery allows me to look at accurate cutting edge algorithms and to understand what that non-parametric problem might be, right? And then from there, I can actually take that data, test the assumptions in the direction of the relationships, and then compute the edges, right? From causal inference, then procedures on VIA 4, as I said, some of them are on SAS 9 and VIA, and then there are others that are exclusive to VIA, right? And that's one of the reasons why we're encouraging all of our customers to plan for their modernization to move from 9 to VIA. Because of the compute and the architecture of VIA, we're able to do more sophisticated math on VIA than we are on 9 with minimal compute requirements, right? So proxy effect, superlearner, deep causal, and deep price, those last 3 rows there are all exclusively on VIA. And then if I want to do specifically about deep causal and deep price, these are advanced causal AI for real world decisions. When I take all of these different analytics and I'm able to string them together through engineering, I can automate these processes and establish my first agents, and then go down to the path of a trusted AI workflow. And so looking at a more reliable effect estimation for stronger decision support, and learning complex patterns from real world data, not only clinical trials, and reducing risk from overly simple model assumptions, because we like to start like, let me just try to simplify it first, and then we'll grow, and we never grow, right? We get overwhelmed, and we have good intentions, but our resources, then we go back to our day jobs. And then we can identify which interventions actually work best, so I can do what if scenarios. What if I unask the question, or I look at the reverse of that patient or the inverse of that patient definition, right? You're able to look at the procedure and realize those outputs and to get naturally generated language interpretations and support. And you're able then to actually visualize not only the SAS procedures, but also if there's DoI, a Python package, or an R package, you then can visualize the estimands, or you're able to actually then build a UI around it and visualize and understand which package or which method is best for my data and my project. So we're not forcing you only to the SAS procedures, although they are rich and they are very valuable. But if you have a polyglot system where you're actually bringing in many, many packages and many, many methods and approaches, you're able to compare them and actually make a very informed and data-driven decision on how I want to be able to test these relationships and the assumptions that I'm willing to make or that I must address for my regulators. And I'm able to do that very, very quickly, okay? And then, and the very last, right, how I'm going to be able to, along the path with SAS, build out my agents. Now if you will have an agentic workflow, if you have an agentic task force, you can take your existing code today and start your agentic journey and start building out agents that you have validated according to your corpus and according to your standards, your corporate standards. But you can also partner with us and give us feedback on what we are doing to help inform and establish this causal AI workflow. So asking a question in plain language, this is one of the things that we'd love to be able to do. Once I do that, right, I need that context. So RAM, all right, if you've heard it, at this solution session, which is the Retrieval Agent Manager, I can pick the tool that I want that's most appropriate based on the question that I'm asking. If I'm defining a patient population, or if I'm defining a procedure of interest, right, then I'm looking at an association first, and then I'd like to be able to use this particular causal analysis method. So then it will actually propose a causal structure and confounders, and I, the user, because I'm keeping the human in the loop, can actually validate and verify that this is the way I would love to go. right? No, actually, from a clinical perspective, I need to actually keep this particular variable in, even though maybe the logistic regression dropped it in the analysis. Then I can estimate that treatment effect and the heterogeneity of my data. Is it diverse enough for me to actually test enough what-if scenarios? And then finally simulate those scenarios and policies. Once I've met all of the criteria and I'm able to use my MCP server or literally click a button after I've validated and I've done my checks, it will give me now, or it will return an auditable recommendation. This is the recommendation of the workflow for the causal analysis that we're providing to you as the user, and you can still customize it. If any of you have used Model Studio in VIA, it's a very similar setup. I can do a SAS generated pipeline of analysis, right? It's a deterministic models usually. This is going to follow the same logic, so it's actually standardized to the workflow that you're used to in SAS VIA, but now it's actually more specified for the causal types of analyses that we want to be able to do. Once I have all of the plausible drivers and I've checkmarked and said, yes, this is the way I want it, it will run it and you'll have the logs that are auditable for all of your regulators. This is the end of my talk. I thank you all for joining me today. Before you go, I like to do selfies with my audience. So I know some of you were in the last one. If you wouldn't mind, everybody make a funny face or a silly face or a smile, right? Are you ready? Say causal. All right. So now, how can I support any of your questions? What questions do you have?
How do you integrate this into an algorithm development pipeline in such a way that it's there throughout the life of the algorithm and monitor?
Sure, that's a great question. So one of the things there are a couple of ways you can do that. One is that if you want to actually affect the code, right, and be specifically in control of the code, you can, all of these things that I'm telling you that are already there at SAS, you'll have access to, right? If you don't want to do that generated pipeline, you don't have to. Let's just say you want to do the generated pipeline, but include that pipeline in a larger algorithm, right? Algorithmic pipeline. You can do that. Today in Model Studio, you can actually put in a pipeline for text analytics, as well as a deterministic auto-tuned pipeline or an immediate target pipeline, for example. And I can do a lot of comparisons that way. Another way that you can do that, a little more advanced, is something with intelligent decisioning. So you have different steps across your algorithmic path. So first step is this. If you get this kind of result or you hit these parameters, then you go down this path. And if not, then you go down this path. So the entire algorithm can be as sophisticated and as wide as you'd like, or as simplistic as you'd like. And if, like I said, this is modular, so if you would like to be able to take some of the procs specifically, or focus on maybe an option that is within that proc, because that is your corporate standard, you have that flexibility. Same thing with intelligent decisioning. The business rules that you put in can be suggested as well as your corporate standards, right? Your lexicon. So if the algorithm and your procedures, your SOPs say, if this then that because of your company's procedures, not because of anything else, then you're able to actually incorporate that as well.
My question is related to the RAM. For retrieval augmented agent or the manager thing, what is the digital brain behind it? Is it configurable to our own LLMs?
Oh, yes, you can actually configure it, but Pritesh, do you want to take that? Pritesh can talk to it in a little more technical detail, but yes, from my understanding is that it is actually configurable to whatever you want. It's LLM agnostic.
Correct. So RAM is just kind of a orchestration layer, and we can bring in any LLM you want. So what we did is we orchestrated it. We can hook up all the pipes, feed any unstructured documents and everything, give a proper context. Context can be unlimited, and then start chatting with it, basically. So anything available, we are LLM agnostic. You can have your own personal LLM with RAM, just an orchestration layer.
Any other questions? These are really great. Well, thank you for your time. Oh, there's one more question. Sorry.
I have a question related to Copilot. Is it the same with Copilot? Is Copilot LLM agnostic?
All right. So Copilot has a different story. So there are multiple Copilots in SaaS. So some Copilots are more like you can chat with your dashboards, you can chat with your RAM, you can chat with your intelligent decisioning. So that's one sort of Copilot. What SaaS has done is it created its own SLM so that when you talk to it, it will give you an accurate SaaS code. But the SLM then goes and talks to the LLM on the second side. So that's a bit of a different. And then the other Copilots are more like you can literally like a code gen, you know. Same concept, SaaS can reach out to any LLM we want and it will give you an accurate SaaS code that SaaS is trying to train. So there are two ways to do it. Any other question, guys?
If you have any other questions or if you have any ideas or you're curious, I invite you to come to the HLS booth, to the Health and Life Sciences booth, in the entrance of the exhibit hall in the Innovation Hub. We're happy to go through these demos in more detail or any other questions that you might have around your workflow and how SaaS Avaya can help you help support your challenges at work or innovate with you. Thank you and have a great afternoon or the rest of your evening.